If you are an Android developer, then there is a very high chance that you have already used the class LiveData. And do you know how it is working internally? Have you ever created it by yourself? If not, let's do it in this video. My name is Sagar Malhotra, and today in this video we are going to create a custom LiveData class, and by the end of this video you will be able to configure it according to your needs. So let's get started. Just in case you don't know how you can use a LiveData in your Android project, then let us just see this example. So I am creating a LiveData with this mutable LiveData constructor, and this will hold a string value. And here in this main activity I am observing this, and the lifecycle owner is this activity. And then with this new value, every time I am just putting a toast here. So that simply means whenever this value in the LiveData changes, this callback will be triggered and we are going to see a toast in the screen. And inside our view, inside of our composable screen, we are having three buttons. First button adds A, that means the value is changed. Then second button adds B, then the value is again changed. And in the third button, what we are doing, we are again adding a new observer. So again this activity will be again observing with a new callback, and that callback just shows us some different toast message. Okay, just let me know in the comments if we are adding a new observer that has the same lifecycle owner, then what will happen for our existing LiveData object. Will it throw us an exception? Will it replace our previous callback? That means this callback will be no more triggered after this is added, or both will remain. So quickly stop this video and comment down. And now let us run the application, and it is already running. So I am clicking on increment, then value is added, then B is added, and when I am clicking on change callback, then a new observer is added. And when I am clicking on increment, then both the observer are still there. That means there is no unique value for a single lifecycle owner. Okay, and we can either mimic this exact behavior or we can also customize it. Maybe you don't want to keep this previous observer, then you can still remove it, or if you want to keep them both, you can also keep them both. And if you want to just not update this and keep the previous one, or maybe throw an exception, if you are trying to observe with the same lifecycle owner, then you can also throw an exception or just implement any custom behavior that is not present in our mutable LiveData. So let's get started. So if you don't already know, LiveData is based on a very famous design pattern that is called as observer pattern, and let's understand that first. So suppose a scenario, you are the younger brother in your family, and there is also your elder brother, and then there are parents. So if you are doing something, so your elder brother is just noticing you. That means elder brother is observing you. And if you are doing anything, that means if you are doing some action, or if the value changes, that means if any state changes occur for this object, then the observer, your elder brother, will know, and then your elder brother will notify parents. So this is the entire thing that you need to know about observer pattern. There are three people involved here. One is this you that is getting observed. So this is going to be called as observable, and this the elder brother who is observing you. So who is noticing every action that you are doing, every changes that you are doing. So this elder brother is called an observer. The elder brother who is observing you, that means the observer who is observing the observable. So LiveData falls in this category. It is a data holder class that will act as an observer, and it will hold all the observables. That means there can be multiple siblings who this elder brother is observing. And if state changes, then it will notify the subject. That means it will just trigger a callback or anything that you may want to implement. So we will just implement all these things. So maybe now you can understand it better. These are the observables which this observer is always looking at, and if anything changes from these ones, then whoever is responsible, whoever is the callback that we have to trigger, so we will just trigger it. And we just need to create this observer class, and all the things, managing all the observables and calling all these things, will be the task of this observer. So we just have to create this observer class, and let's do that. So let's create a simple class that will be named my live data, and let's see whatever values it is holding. Okay, let's keep it simple. We will only observe one observable, and that is also how LiveData works. Actually, it holds a value, and if that value changes, it triggers a callback. It triggers all the observers, whoever was registered for this value change. So we have to just hold one value. So first of all, observer will hold one value. So this is my live data class and it holds a observable value. Right now we will only listen to any integer value changes. So let's create a var, that is value, and that will be type of integer. And let's initialize it with 0 for example. We will modify it later. And now we can do two things. Either we can add a getter and setter which will just trigger the callbacks, but this is Kotlin, so we can just do it like so. Let's add a setter. If this value is set, then what we are going to do, we can just write field, that means this value field equal to this new value. So new value, and like this. So this will work. So that means if we are doing my live data dot value equal to suppose 1, then this function will be triggered. But if we are not writing this, then the same thing is happening. So we have to do something extra. That means we have to notify all the observers. So when the value of this changes, then we have to notify all the callbacks. So there will be a list of callbacks. That means there will be multiple callbacks. So we have to also store that. So notify all observers. So let's create this function, and this is going to be a private function. So we will see how we can implement this, but now you know that if this value is going to change, that means if we are setting this value, then this will be triggered. So field value will be updated and we will notify all observers. We will see how. So for this function, what we have to do, there should be a list of all the observers that are observing to this value. So let's also store this list. So val, and that should be private val, a list of, I said observers, right? But there is no observer class that we just created, or we don't want to use any existing one. So what we have to do, we have to actually trigger a callback. See how live data works. Whenever this function is called and if anything changes, then this callback will be triggered. So maybe we can store a callback here. That can work. Okay, so we will store a callback, and for this callback, what we will have, just see this closely. This returns us a new value, means whatever was the type of our live data, so that value will be updated, that new value will be present here. So we have to pass an integer because we are storing value as integer. So a new integer value will be created and we don't need any return type. So list of callback, as simple as that. And so now we have a list of all the callbacks. So how we can notify all, we just have to trigger this callback. So we have to iterate over this list. So list dot for each, and we will just trigger it dot invoke with the latest value, and the latest value is this value, as simple as that. So all the callbacks that are stored in this observers list will be notified, will be triggered, and we just have to now store any callback in this list. And how this live data is doing with this observe method. So let us create that. So that is going to be a public method, fun observe. And if you see, this is also a lifecycle aware data holder class. For this observe function, if you can see, this is also taking a lifecycle owner object. Live data is lifecycle aware, means when there is nothing visible on the screen, when your activity or your lifecycle owner is destroyed or stopped, then there will be no updates sent from this live data class, and we are also gonna do that thing. So initially we don't need to do that, we just have to take a callback. So let's take a callback, or we can say observer, and this is going to be a callback, and we can simply add it observer dot add. Let's create it a mutable list. So this is gonna work fine. So what we are doing here, we have a live data class that will be always initialized with 0. Let's modify it. We can add an initial value that will be an integer, and let's initialize with this initial value. And when we are creating this my live data class, so we can just pass an initial value and that will be set. And when we are observing to any callback, so that will be added to our list, and now we will be observing for that callback. And if this value changes, that means from some other point of our code this value is updated, then we are just calling this function notify all observers, and we will just iterate through the list and notify all the callbacks. So it is as simple as that. And instead of mutable live data, let's use my live data. Okay, but it is using here string. Let us make it more generic. We can use here t and t. and this is also T. We just have to make it generic, that's all. And now we can also accept string values, and we don't need this. So now just it is not life cycle aware, but we are gonna make it. So this is the observe function, and whenever we are observing, what we are doing, we are simply adding a new callback. That means this is gonna work exactly same as our live data. A new callback is added, and whenever we are changing the value, that means with the this button click, our value is getting changed. So this set function is triggered, notify all is triggered, and whoever is listening, this is listening first toast, this is also listening after this message is clicked, so this will start listening. So this is the second toast that is gonna trigger. Let us run this. Okay, first I am incrementing, so value changed to a. That means this function is called, then this is the observer which was already observing, and decrement, and I am adding a new callback. So now two functions will get triggered. First is this, second is this. So this is working exactly same as our live data. But now this should be lifecycle aware. So let's do that also. We need a lifecycle owner here. Okay, let's see why we need a lifecycle owner. Because we have to just handle one thing. When our activity is getting destroyed, then what we have to do? We have to just clear all the observers. That means we don't have to notify any more now. So we can get an instance of our activity, and we can just check if the activity is in the destroyed state, or if it is not in the resumed state. But you may also want to use it in a fragment maybe. So for that, you can see in the component activity, it is implementing this lifecycle owner interface, and we can just use that here. So let's use this lifecycle owner. Okay, we have to also store this lifecycle owner inside of our observers, because you may want to customize this thing. You may want only one activity to have only one callback, and if you are adding multiple, then you may want to update it, or you may want to throw an exception. So instead of your mutable list, you can create a mutable map here, and mutable map of. So now we are gonna put, so this has a put function, and like this. And for our notify all function, we are iterating over the map. So we are gonna have a entry here. So for our entry, we can just get the value. We can just get the callback from this value. So it dot entry dot value dot invoke with the latest value here. So this value is the value from our map, and this value is the field which is our initial value, which value we are observing to. So now this is gonna get this parameter this, but we haven't changed anything, right? Let's pass it here too. We actually have not changed the logic here. We are just storing the lifecycle owner also. But where is the logic to actually stop observing, or where is the logic to remove the observer if any activity is destroyed? If the lifecycle owner is destroyed, where is the logic for it? Okay, so now the requirement is when our activity is going from any other state to destroyed state. That means the activity state is changing. So we have to also observe to that. And for that, lifecycle owner provides us multiple methods for it. You can see lifecycle dot add observer. So we need a lifecycle observer, and now this live data is dependent on any other observer. We want to add this extra functionality to observe to our lifecycle. That's why we are depending on this lifecycle observer. So let's create a lifecycle observer. Uh, Lifecycle observer. Okay, here you can see lifecycle event observer and lifecycle observer. Both are interfaces. And what is the difference? Lifecycle observer is just an empty interface, and a lifecycle event observer, it provides us a callback on state change, and we have to customize it. That means we can we can add a class implementing this interface, and then we can implement this on state change. So let us create a inner class here. Inner class, let us name it my lifecycle event observer. and that is gonna implement lifecycle event observer, and we can just override this one function state changes. And what we are gonna do is we have to just check if the state is destroyed, then we have to remove the observer, as simple as that. So let's get the current state, and that we can get from this source lifecycle owner. So lifecycle owner dot lifecycle dot current state. If current state equal to lifecycle dot state, so there is a enum class, and we have to check if it is destroyed state. So if current state is destroyed, then what we have to do? We have to just remove it, or we just have to stop observing. So we can just call a remove observer, and now this needs a lifecycle owner. So let's pass it there, and it will be present inside of this private well lifecycle owner. This is my lifecycle event observer, and we have to pass it here, and we have to remove this owner because this owner was destroyed state now. And now we need another private function to remove. Private function remove, and this takes owner lifecycle owner. And how we can remove it? Observers dot remove. We just have to remove it from this private list. So we have to remove this owner. That's it. Okay, now that sounds fine. Let me also add a log here. So we are just calling this remove observer, and it is removing it from the private list of our observers that we have created. So there will be no callback that is anymore triggered from this lifecycle owner. So now that sounds fine. Let us understand the flow from the basic. So there is a live data, and the value is getting updated. So if the value is getting updated, we are notifying all the things, and we are iterating over the list, and notifying all the callbacks, and the callbacks were stored with a lifecycle owner and a callback. So inside of this observe, what we are doing, we are having a lifecycle owner, and we are observing to that lifecycle, and we are adding the callback to our private list so that we can trigger all of them. So I think that will work fine. And now just the added functionality is whenever the application whenever the activity stops, then we are gonna remove this observer, right? So let's check it. So now we can increment, value is incremented, decrement. So previous functionality is working fine. Now we have added a callback, so two callbacks are present now. One, and there was only one, right? Yes, there is only one. So that means we might have changed something. Okay, yes, that is because for one owner, for one lifecycle owner, that means for one activity, there can be only one callback. So we just have changed that behavior. So previously, this callback was saved inside of this observer map with this activity. So this activity and this callback was stored. But when we clicked on this function, so for this activity, a new callback is stored. So we can either throw an exception. So how you can throw an exception? What you can do is you can just check the previous uh, observer. So we are gonna check observers from this owner. So if this previous observer exists, then what we are gonna do, we can either throw an exception. So that is completely up to you. If you are adding a new observer, you want to maybe override it, or you may want to add multiple times. So how you can add multiple times for one particular owner? There are two scenarios. Either for one lifecycle owner, you can store a list, or you can store a set of these callbacks. So for activity, there will for this main activity, for this lifecycle owner, there will be multiple callbacks stored inside of my live data class. So this will be stored inside set, and this callback will be also stored. And right now we are only storing one, and this will be overridden. And if you don't want to override, you can just use here put if absent function. So observer dot put if absent. So with this put if absent, that means if there is any existing value, then don't update it, and if there is not any existing value, only then update it. Let me also show you that. So now that means this callback will never be stored, but we are still adding this, right? So there will be a memory leak here. Even when observers list will not be updated for this callback, there will be a lifecycle event observer still created, and that will be added to this owner.lifecycle. So that is a problem. We have to also remove this lifecycle observer when we are removing any of our own observer. So we have to also remember that we are adding a lifecycle observer. So make sure you have to also remove it. So there is a memory leak here. So right now there is no overriding of callback. Let us just see that. So increment a b and changing the callback. So change will not be triggered. You can see still the same toast message is here. So that is how you can customize your implementation of LiveData. So there will be only one observer, but how we can add multiple observer? Either we can add a list, or maybe you can just instead of storing a lifecycle owner, we can store a lifecycle event observer. Now because this observer is created as a new object every time, so that means every time we are calling this observe, there will be a new key every time, and there will be a new value. Or even if this is just an old value, doesn't matter. We are gonna add this lifecycle observer here, and we are gonna remove. Okay, for this remove function, we have to remove this. If the state changes, then we have to remove this lifecycle observer. I hope you understand this. Remove this lifecycle observer. Okay, in this function, whenever there is a state change, then we are removing this as our event observer. So from our private list, this is getting removed, but this was still added to our life cycle. So let us also remove it. We have to also call this. We have to also remove this, remove observer, but we don't have the owner, but here is the owner. So what we can do is we can put it inside a function, remove lifecycle observer, lifecycle observer dot. Now I hope that makes sense. Okay, now what we are doing, for every callback, we are adding it inside of our observer list, and when we have to notify, we are gonna trigger all the callbacks. So this will be triggered and this will be triggered as many times as we are clicking on the button, and that is also the behavior of our live data. So let us run this increment. So this value is shown second time. We are adding one callback, so two toasts will be here. We are adding two callbacks, so total of three callbacks are present. 1, 2, 3. That's it. And we can just change this my live data to mutable live data, and this is gonna work exactly same. Now the initial value is also getting a toast message, so we can also add that inside of our custom observe function. So when we are observing here, so what we can do is we can notify all observers after adding this. After adding this, we can notify all the observers, or maybe just notify this. So for notifying this, we can just trigger this callback, right? We can just trigger this callback with the latest value, like this. So whenever we are calling this observe function, so first of all we are gonna release the current value, and after that this will be stored inside of our private map or list, whatever you can say. So right now for our existing live data class, we can click. There is only one observer. When we are adding a new callback, so this callback is also triggered. So that means whenever this observe function is getting called, so this callback is triggered again, and then we can decrement, and now there are two callbacks. We can click again. Now there should be three. 1, 2, 3. So three callbacks are here, and let us add my live data. So for my live data class, all the things will work exactly same now. First, initially a toast message will be triggered. This will be triggered. When we are adding a callback, toast is again triggered, and now there will be two callbacks. If you are adding more, then for while adding, there is a callback triggered, and when we are doing any value change, then all the three observers are getting triggered. So I hope now you understand how we can implement our custom live data. And if you want to change anything here, if you don't want to trigger the initial callback when you are actually starting to observe. So when this function is called, we are starting to observe. And let us also see what happens when we rotate the phone maybe. So rotate, value is changed to 0. And why 0? Because we are initializing it inside of our activity, and that is not our problem. That for that we have our view model class, right? So the thing to notice here is whenever we are rotating our device, the previous observers are getting destroyed, and we have to see that inside of our logs. So my live data, let's clear this and let's rotate. When we are rotating, removing our observer because state is changed, and state change is destroyed state. So whenever we are inside of our destroyed state, so we are removing the observers from our list, and what is going on inside of that? We are removing it from the list and also the lifecycle owner. So this is also getting removed, and when we are rotating it back, then again all the observers are getting removed. So I hope now you understand the internal working of live data, and you can create your own live data for your specific use cases and behavior. So if you like this video, if you learned something new, then make sure to subscribe to the channel. It motivates me to keep posting such videos. Thank you for watching.